So, what is today's date?
2008.
Ashadh 15th, right? They say Ashadh 15th means is the day to have Dahi Chivra in Nepal, right? Right, famous. I already ate it. You also try to eat. Otherwise, when you return back home, manage and have, right? And recently there was the result of SE 2081. And do you know our result?
Yes.
How have they done?
Food
See,
chutney.
it is outstanding, really outstanding government. In the history of Anubhav, who has deserved GPFO? Raju Kumar Saha has deserved GPFO. BN Balami has deserved 3.96. Pujana Swesta, Viveki Kesi, they have deserved 3.92. Sasanka Acharya 3.89. Ritika 3.81. Out of 21, near about 17 students, they deserve more than 3.6. Give them a big round of applause. GPA 4, it's not a joke. So that's a miracle. In every sector, in theory, in practical, you have to deserve how much marks? More than 90%, right? So this batch is also capable. You try right now onwards. Your turn will come next year, 2083 SE batch. So you also are capable, boy. Try. Mouth, bug bug, work, thap thap. Then what to do? First of all, you understand the matter. How is it? What is the reality? And express. What happened, Kumar? One person must speak. If you want to speak, please come here. So today is Sunday, means presentation day, theory presentation day. And let's check who has to send this one. Who has to send the Gmail? Adarsha Karki. Adarsha Karki has to send here the thing. What is that? Okay, Adarsha Karki. Atomic structure, force and motion. Yes, and two.
Yes, sir.
How many you have to send?
3.
Three. One is still left.
Yes, sir.
So today you want to do a presentation of force and motion.
Yes, sir.
Okay, that's better. Force and motion you want to present means, let me download force and motion. Already downloaded. So that downloaded file we'll check later on. And once let's give a glance upon this one. Class, the class is 9. Okay. Class 9. It takes time. Let me give you a number, right? But in which number it is there?
121.
21 only? 21? 121. Oh, 121. Okay. It's not you.
It is separate.
Right? This is the page, right? Okay, force and motion. So, there must be equations of motion. How many equations of motion are there? B equals to U plus AT. S equals to V plus U by 2 times T. S equals to UT plus half AT square. V square equals to U square plus 2AS. And it's the pen. And uniform velocity, non-uniform velocity, acceleration, Newton's laws of motion, elasticity and plasticity. This chapter is also quite important. This is the chapter of physics. So without wasting time, now I'm going to welcome on the stage today's presenter. He is none other than our hero, because he has prepared this one, means it's great. Is it PDF or what? Oh, the boy, what is this? This is PDF?
PDF.
Why PDF? Why did you make PDF? You have to make PPT. Remember, other next two works are also there for you. So those will be presented by others, but prepare and submit. They must be in PPT. Okay. Please welcome Adarsha Karki for his presentation. Okay.
Namaskar and very warm good morning to you all. As always, it's me Ashadh Karki from grade 9. Today I am going to present chapter Force and Motion. And now without delay I would like to start my topic Force and Motion. In this chapter we are going to learning goals as you can see. After this chapter we will be able to notice all the difference between scalar and vector unit displacement velocity, and I am going to explain the retardation between acceleration and velocity, and definition of acceleration due to the gravity, and how to understand the centripetal acceleration and projectile motions. Now without delay I would like to start. At first we are going to learn about motion. To describe completely the motion of an object, you need to know three things that are position, velocity, and acceleration. Position at one single time, Cartesian coordinates, and needs or reference point. It needs at a single time only. At velocity, speed, scalar, and direction to vector, and acceleration, magnitude, scalar, and direction to vector. Moving from place to place. As you all know, moving from place to place, speed scalar, average speed equal to distance traveled by time travel, or b equal to d by t. You can also note it in your rough copy. And acceleration 2 hours to go LA 180 km and 4 hours to come back. Air speed equal to 180 km plus 180 km by 2 hours plus 4 hours equal to 60 km per hour. Instantaneous speed equal to speedometer reading. As you can see here, velocity vector. Average velocity equal to displacement by time to travel. Displacement is equal to straight line distance between starting and ending point with direction pointing towards the end point. Now it's another example. 2 hours to go LA 180 km, 4 hours to come back. Average velocity equal to 0 km by 2 hours plus 4 hours equal to 0 km per hour. Instantaneous velocity equal to speedometer reading plus direction. As you also can see here, one figure is displayed here. Here is shown that the displacement is here also shown. Displacement is a vector quantity between 2 points. Distance is the actual path traveled. Special case constant velocity. If the velocity is constant, then the speed is not changing, the direction is not changing. In straight line motion, we choose one direction to be positive, the other to be negative. For example, at a track meet, a runner runs the 100-meter dash in 15 seconds. What was the runner's average speed, average velocity? V equal to d by 2. Now we are going to learn about acceleration. If the velocity changes, then it is said to be acceleration. Change in magnitude and or the direction. For example, cars slowing down or speeding up the earth around the sun, a ball falling down. Average acceleration equal to change in velocity by time for change. You can see a formula. Acceleration. Acceleration is a vector. Magnitude, rate at which the velocity is changing. Direction, how is the velocity changing? If the velocity and acceleration are in the same direction, the speed increases. If the velocity and acceleration are in opposite direction, the speed decreases, as you can see in figure. From here it is increasing, and from here it is decreasing. And now your question: which of these? By seeing this figure, you can answer this question: which of this is accelerating? Obviously, this is a car on a circular track going at a constant speed. Special case gravitational acceleration G on G. Objects falling at the surface of the earth all fall with the same acceleration, G equal to 9.80 meter per second scale down. Without the effect of air resistance equal to free fall, dropping distance equal to D equal to 1 by 2 gt square, T equal to time for falling. As you can see here, one example: a ball is dropped from a tall building. How far does the ball drop? In 0.50 seconds square. You can see a total distance traveled, and by using this formula we can find how much it can go down at the time 0.50 seconds. By using this formula, we can find that it travels 1.2 meter in 0.50 seconds square. As another example, we are throwing a ball up, letting it fall down, and there is a gravitational acceleration always down when the ball goes up as well as when it comes down way up. Acceleration opposite velocity, so slowing down, slowing way down. Acceleration same direction as velocity, speeding up. You can see here when we are throwing up, it is going slowly, but when coming down, it is coming faster. And another topic is the uniform circular motion. Constant speed, but direction is changing all the time. There is an acceleration points toward the center of the circular path called centripetal acceleration, or A is equal to v square by r. V equal to speed, r equal to radius of the circular path. As you can see, by cutting direction, the string keeps the ball in a circular motion. You can see, if you cut the string, the ball will continue in a straight line. It says that if you do not cut any part of this, it always revolves in their place. If you cut a little bit also, it goes straight in a line. Another is uniform circular motion. And example is, a person drives a car around a circular racetrack with a radius of 70 meter at 10 meters per second. What is the acceleration of the car? To find it, we have to use this formula v square by r, and by using this formula you can find easily answer. And gravity with high speed. A zookeeper wants to feed a banana to the monkey with his cannon. The monkey always let go of the branch when the banana is shot. Where should he aim? Above, below, or none? As you can see here, monkey is in a tree branch. Gravity with slow speed and aiming above the monkey's head. Force and net force. Forces are capable of producing a change in velocity only if the force is unbalanced. Force are vectors. If there is a net or unbalanced force, the motion will change. There will be an acceleration. Now the another topic is laws of Newton. An object will remain at rest or in uniform motion in a straight line unless acted on by an external unbalanced force. Now it is said here that our object will remain in rest or uniform motion unless there is applied external force or unbalanced force, and the greater the mass of an object, the harder it is to change its motion inertia. An object does not need a force to keep on moving. Examples of forces apart from gravity in your daily lives: force is transmitted through contact. There is even one example to know. An elevator is being lifted by an elevator shaft at a constant speed by a steel cable. Forces on the elevator are such that the upward force by the capable is greater than the downward force of gravity. The upward force by the capable is equal to the downward force of gravity. The upward force by the capable is smaller than the downward force of gravity. In none of you, and this answer is the upward force by the capable is greater than this downward force by of the gravity. You can see as an example, an object keeps on moving the way it was unless a force acts on it. Explain those examples using Newton's first law. In Newton's first law, it is said that if body remains in uniform motion unless an external force is applied, so blood rushes from your head to your feet while quickly stopping when riding on a descending elevator. The head of a hammer can be tightened and onto the wooden handle by banging the bottom of the handle against the hard surface. To dislodge ketchup from the bottom of a ketchup bottle, it is often turned upside down and the thrusted downward at high speeds and then abruptly halted. Headrests are placed in cars to prevent whiplash injuries during rear-end collisions. While riding a skateboard or wagon or bicycle, you fly forward off the board when hitting a curb or rock or other object, which abruptly halts the motion of the skateboard. As you can all see here is explained that all in Newton's first law. And unbalanced force, its formula equal to mass into acceleration or acceleration equal to unbalanced force by mass. For the same force acting on different object, the heavier the object, the smaller the object. For a given object, the larger the force acting on it, the larger the acceleration. Different objects will have the same acceleration if a force proportional to their mass is applied on them. As you can see here is one example. A man is trying to pull this, and there is another question. A net external force of 21 Newton is applied to a mass of 3 kg from Newton's second law. What will be the resulting acceleration? In A equal to 63 meter per second square, and B equal to 21 meter per second square, and C equal to 7 meter per second square, and another is 0. And here is centripetal acceleration caused by a force. As you can see here, one example of it, many examples of it. For every action there is an equal and opposite reaction. It is also said in third law of motion of Newton. Force always come in a pair acting between two different objects. The earth attracts you towards it by gravity you attract it towards you with the same force. When a train and beetle collide, the train and the beetle will have the same force hitting them. When you walk, you push on the ground back, and the ground reacts by pushing you forward with the same force. Recoil from these are some examples. Fried recoil: the bullet is pushed forward with the same force that pushes back on the rifle. Uh, if you if you are stranded in space with nothing, you are doomed. A large truck breaks down out on the road and receives a push back into town by a small compact car. While the car is still pushing, the truck is speeding up to get off the to cruising speed. The amount of force with which the car pushes on the truck is equal to that with which the truck pushes back on the car. The amount of force with which the car pushes on the truck is smaller than that with which the truck pushes back on the car. The amount of force with which the car pushes on the truck is greater than that with which the truck pushes back on the car. Neither the car or not they exert any force on any other. Answer is D number. So another question is: a large truck breaks down out on the road and receives a push J. Gravitation F is equal to gm1 m square m2 by r square. F is equal to force of gravity, and g equal to 6 into 6 7 into 10 to the power minus 1 nm square per kg square. M1 and M2, the two masses that are attracting each other are equal to the distance between their centers. As you can see here, one example: a car dropping brake, car mass equal to 1000 kg, velocity equal to 20 meter per second, and RKG is 20,000, and their truck mass equal to 3000, and velocity in meter per second is or minus 20 kg meter per second is or minus 60,000. Thank you.
Thank you very much on Adarsha. But he didn't make the slide lesson book, right? So he didn't do any effort also. What did he do? He typed the chapter in ChatGPT, and ChatGPT, what it was given, he copied and pasted. We know this thing, right? Did our syllabus and this slide match? Hello children, did it match or not? So such type of work mustn't be done. First you have to read. Underline the major points. Those major points you have to make slide. So this is the lazy one's activity. Yes or no? To make it, it doesn't take more than 5 minutes. Type in the ChatGPT your topic and give me this one. Everything copy and paste. Email again PDF also. But to make PPT, important things you have to type, take, make slide by slide. That is the system. So next slide onward it must be up to date. So this is lazy one's activity. Sumit suna Allah nahi. Be smart. When we do the work, we have to do work with full interest. Then it will match, no? Very less portion was matching, right? First, why are biting nails you present? First law of motion, no statement is there. Is there no statement? Everybody continues in the state of rest or uniform motion in a straight line unless an external force is acted on it. What the statement? See Newton's second law of motion. Acceleration produced on a moving body is directly proportional to applied force and inversely proportional to mass of the body. To every action there is equal and opposite reaction. Next thing, balance force, unbalanced force. Why are we making these slides? To revise, not to get information from somewhere else into. All the information is there in the book. That thing you have to do. What is elasticity? What is plasticity? Where is balance force? Where is unbalanced force? Uniform velocity, acceleration. Many things were lacking. So next slide onwards it should not be. Again, what did I say you? First page there must be your introduction, your name, class, roll number, chapter name. In second there must be contents. This one page number, this one page number. Yes or no? In that way it must be done. Right? Please be sincere. So such type of work does not assist you in your life. So learn. Actually, these works are given you to be smarter one. Class 9. Class 9. Now we will see from this book. Right? So this is government book. Government books. Person where is given. These are government books. Yes. Chapter number 7, right? Chapter number 7 now we are going to do. This is chapter? Hello? Force in motion. This is of government book. So see, from Kathmandu to Batuli. The bus journey of Batuli. I think Batuli means a lady is there, one girl. She went from here. So how long distance? See? She is here. But shortest way is a shortcut. This shortcut is displacement, right? And from here, which map she has taken, what is that? Distance. So, average speed, what is the formula? D by T. Average velocity, S by T. Here D means distance, S is displacement. S is scalar quantity. No, so distance is scalar quantity, where the displacement is vector quantity. Vector, scalar. So these things were discussed. One formula was there. What is that? A equals to B minus U by 2. What is B? What is B? Final velocity. What is U? What is T? Time taken. How do you define acceleration? Rate of change in velocity. Rate of change in velocity with time is called acceleration. So these things, see, so many educational motions were there. We have to derive this. Now I am going to provide you some work so that there will be revision. Figure, action. Here to every action there is equal and opposite reaction. So if you continue like this, marks also will come like that. Sometimes G also comes, N also comes. NG, non-graded. They neglect, what are spectacle? Oh, now you have to get human. Otherwise, how can your eyes problem? Why? It cannot be. Why? Look. What happened? Why it cannot be? Oh, it can be. Okay. At first, let's discuss this MCQ. Eh? Read first question. Velocity time graph. Velocity by time. What is that? Yeah, velocity time graph means velocity and so what is the relation of velocity and time? B by T is what is B by T? Like if there is velocity and time, here velocity, here time. If A goes line, then what is this? What is that? Acceleration. V by T is acceleration. Distance and time, speed. Displacement and time, velocity. I remember. Second one is number B. What is the question? Which of the following is the displacement time graph? Sorry? Number C is displacement time graph? True? Okay. Number C. Stepping down from a running bus is dangerous. Stepping down from a running bus. On which of the following basis the statement can be justified? Inertia of rest, inertia of motion, second law of motion, third law of motion. What is that? Inertia of motion. Okay, this one. Which statement about action and reaction is true? Which one is true? One cancels another, both act on the same body, both are equal and act in the same direction, act on different bodies. Which one is correct? Act on different bodies. Action and direction act on, reaction act on different bodies. Number 4 is correct. Eh? Which of the following is the application of elasticity? Application of elasticity. In elasticity, the body comes to same position again, right? Which one? Beating iron into sheets. That's right. Number F. A loaded truck and a car are moving with the same velocity on the road. If brakes are applied on both vehicles with equal forces, then which of the following statement will be true? They are moving with the same velocity on the road. Distance covered by the truck is less than the distance covered by the car. Distance covered by the car is less than the distance covered by the truck. Distance covered by the truck is equal to the distance covered by the car. Distance covered by the truck is not related to the distance covered by the car. Which one is correct? Sorry?
Distance covered by the truck is not related to the distance covered by the car.
Brakes are applied on both vehicles with equal forces. Distance covered by the truck. Which one is correct? Second one is correct. What is that? Distance covered by the car is less than the distance covered by the truck. When the same brake is applied, truck takes a little bit long time, or it travels more distance and stops, car this. Do you know it's because of inertia of motion? Inertia of motion. More motion, more distance travel, less motion, less distance travel. Right? Now your work is page number 124. Do you have rough copy? Take out rough copy. Let me give you the work. 4, 1, 2, 3, 4. This is morning's class work. 4, 1, 2, 3, 4. Okay, start.